Hi everyone. Now we've reached the point in the course where you're pretty much at the end. Yay! So good job hanging in there. So I like to put organic naming at the end of the semester. And the reason for that is that most of you are taking this course, the 100 level course or the 200 level course, because you're using it as a prereq for the next course, which is typically biochemistry. So organic chemistry is the study of carbon. And carbon, being in group 4, means there are 4 valence electrons, which means that it doesn't generally, practically never, form ions, either cations or anions, because the energy to gain or lose those 4 electrons is too high. So almost always carbon will form covalent compounds. Now some courses will put the organic chemistry in with the covalent compound unit. But again, I put it at the end because it's a perfect segue into biochemistry, because biochemistry is the study of carbon as it relates to living systems. Now, just to put this into perspective, you learned that sometimes you make ions. And when you make ions, you make ionic compounds. And there were a few, there weren't a whole lot. You learned a list of pluses, you learned a list of minuses, depending on your course. You may have learned a whole bunch of these D block elements that form multiple ions. It just depends on the course that you're in and how many you had to commit to memory. The negatives or the anions, there was a list and you had to commit those to memory. Then you did simple binary molecular, and there weren't a whole lot of those. Sulfur dioxide, carbon monoxide, carbon tetrafluoride, and so forth. And then you got a short list of acids, and you've learned probably by now that there are Arrhenius acids and bases, Bronsted-Lowry acids and bases, and depending on which chemistry course you're in, the news always gets worse or better depending on your point of view. There are Lewis acids and bases. Okay, for the organic though, carbon is a completely different ballgame. Carbons, because they're in group 4, is what we call tetravalent. And what that means is that the carbons link together like links on a chain. So I can take this carbon and link it to this carbon and link it to this carbon and link it to this carbon and so on and so forth till the cows come home. And then just like links on a chain, just like if I had a necklace or something like that, I can twist it around, loop it around, have things that hang off, little dangly things. It's kind of the same idea with the carbons. So learning carbon chemistry is a whole different ballgame. Okay, so that's the first thing. Secondly, carbons, when only hydrogens are attached, we call those hydrocarbons, they're all nonpolar. And that's because all you have are carbon-carbon and carbon-hydrogen bonds. And so you're like, who cares? It's the end of the semester. I just want to be done. Except that you all are going on to biochemistry, which means you need carbon chemistry that relates to living systems. Living systems have to be compatible with water. Water is decidedly polar, and you should have learned that. Hopefully you learned that. Water is decidedly polar. So if you want like dissolves like, if water is polar, then your solute also has to be polar. And so what that means is that hydrocarbons, or things with only carbon and hydrogen, are great and fine and dandy and well and good and all, but they don't interact with water. So who cares? Why are you torturing me with this? Well, what that means is we have to add other elements. Typically oxygen and nitrogen are the most important ones, although you can add sulfur, phosphorus, and halogens. And so those then create what we call functional groups. So the last unit, depending on the course that you're in, will introduce carbons and naming those carbons, and then adding the electronegative elements that make them polar. If you're in the 200 level class, you have some other things that are added to that. So I'll provide, as I'm able, an overview for the extra things that occur. Those are going to be redox and presumably nuclear decay and half-lives. Okay? So good job hanging in there to this point in the course. We're almost done, so yay! And with that, enjoy this last unit, and hopefully you see some relevance with this in the world around you.